Hello everyone, this is Klotungan working as Assistant Professor in ECE Department, Government College of Engineering, Tanjavur. Welcome to the video on Telecommunication Network Management. With this video, we shall have an overview of SNMP version 2 introduction, then major changes in SNMP version 2, and then SNMP version 2 architecture. It is nothing but system architecture of version 2. Then version 2 SMI, structure of management information. It is nothing but in that SMI we have a lot of sub classifications. It is nothing but information modules, SNMP keywords, module definitions, object definitions, textual conventions, and then creation and deletion of rows, especially in tables, then notification definitions and conformance statements. These are all the things you are going to be discussed inside that SMI, structure of management information. Then SNMP version 2 MIP, you already discussed in that version 1 MIP. It is nothing but management information base. In that MIB, it also having different classifications, sub classification. We are going to discuss that changes of the system group, changes to the SNMP group, and information notification and conformance information, and then expanded internet MIB 2, right? Then last one SNMP version 2 protocol. It is nothing but rules and regulation of that version 2 in data structure of SNMP version 2 PDUs, and then protocol operations in version 2. These are all the things we are going to be discussed in that coming slides, and then finally summary of that version 2. Next, let's start with the small introduction as well as understanding of previous version, last version. It is nothing but SNMP version 1 is the first version of SNMP. It's easy to set up, first thing, as it only requires a plain text community, and then although it accomplished its goal of being open standard protocol, it was found to be lagging in key areas for certain managing applications. For example, it supports only 32-bit counters and has poor security features. These are all the problems, drawbacks. And then a community string is the only security method in that SNMP version 1. Then latest version has addressed many of these problems. It's a small understanding about SNMP version 1. And then in that version 1, we already discussed that organizational model, information model, and then communication model and security model. In that organization model, what's the relation between that manager and agent hierarchy? That's the thing we are going to be discussing in that organizational model. Then information, how we are going to be communicate between that manager and agent, or main device to server, or to different routers, switches, or whatever it may be. Then in that information model, what are the different types you are going to be handled, like MIB, SMI, and basic encoding rules like BER, right? Then SMI is uses a subnet of ASN.1. These are basic things. Then third classification of version 1, it is nothing but communication model. In that communication model, what are all the commands, syntax we are going to be used? different 5 messages we are going to be used here, request and response, trap, UDP based, like that. UDP for no acknowledgement, that one for acknowledgement, trap for no confirmation. Like that communication we are going to use for different devices. Then last classification, it is security model. It's a very limited one in version 1. Then it works well only if there is no attacker. If there is any problem, external problem, there is no external problem, then it's comfortable for version 1. Otherwise, you simply move to the next version. It is nothing but V2. Now, why SNMP version 2? A limitation, having some limitations, some drawbacks in SNMP v1. That's why we are simply move to the SNMP v2. What are the limitations? First thing, it was intended as an interim network management protocol while waiting for OSI network management protocols to mature, and then in TCP/IP it did not do well. It is nothing but CMOT, which is CMIP over TCP/IP was created, but did not do well. Then last point, when the industry realized that CMOT would not overtake SNMP, focus was on enhancing SNMP version 1. These are all the limitations. And then error codes, error handling. This is also some limited things in version 1. That is also one of the reason. Then very simple data types. It having only scalar types. Table manipulation is tedious one. Then new data types can't be defined. This is also one of the drawbacks. Then limited notification. Notification is very important, but here some lagging is there. Like that, likewise, it is unacknowledged, right? And then the agent does not know if critical notifications, it is nothing but traps, have not reached the manager. These are all the limitations we are going to be faced in SNMP v1. Then performance wise also very low or very poor. So we get one scalar at a time, not multiple. And then not suitable for larger network. It's a limited networks. Then transport dependency, that is also one of the drawback. Then lack of hierarchies between that manager and agent, not manager to manager. It's not possible. Then security, very important nowadays. That is also having some lagging, very poor security, minimum authentication and authorization. These are all the drawbacks we are going to be face, limitation we are going to face in that version 1. That's why we are simply move to the SNMP version 2. In that SNMP v2 simply overcome that performance and security problems in that version 1. Then secure SNMP was proposed in July 1992 to solve these problems in version 1. SMP, Simple Management Protocol, was also proposed in July at the same year, 1992, to extend the SNMP functionality. And Secure SNMP plus SMP, Simple Management Protocol, it is nothing but version 2, introduced in 1993. Then major security flaws was detected in this proposal and the security aspects were dropped, and the result is community based in SNMP version 2C at the time of January 1996. Then simply move to the next topic. It is nothing but version 2 architecture, SNMP version 2 architecture. In this architecture of version 1, it having the 2 key enhancements. What all that means? 8 messages instead of 5 new messages. It is get bulk request 1 syntax, inform request and report. Second point, 2 manager applications communication, hierarchical and distributed network management. And then come to that messages, version 2 messages. The messages get request, get next request and set request are the same as in version 1, same thing, and are generated by the manager application. The message response is also the same as get response in version 1. Same thing we are going to follow in that version 2 also, and is now generated by both agent and manager applications. That's very important. It is generated by the agent application in response to a get or set message from the manager application. It is also generated by the manager application in response to one inform request message. It's one of the syntax from another manager application. Then inform request manage is one of the syntax is generated by a manager application and is transmitted to another manager application. As mentioned above, these are all the syntax the receiving manager application responds with a response message. This set of communication messages is a powerful enhancement in version 2 since it makes two network management systems interoperable. So the message get bulk request is another one is generated by manager application. It is used to transfer large amount of data from the agent to the manager, especially if it includes retrieval of table data. That's very important. The retrieval is very fast and efficient too. The receiving entity generates and fill data for each entry in the request and transmit all the data as a response message back to the originator of the response. Right? Then architecture, SNMPv2 architecture. In this architecture looks essentially the same as that of version 1. From that diagram, you can understand the same thing. It's look like a similar. However, there are two significant enhancement in SNMP version 2 architecture. From the diagram, first, there are 7 messages instead of 5. Second one, two manager applications can communicate with each other at the peer level. The another message, report message, is missing. This is because it has been defined as a message. Version 2 working group did not specify its details. It is left for the implementers to generate the specification. It is not currently being used and is hence omitted from the diagram. Right? This is the architecture. Then SNMP version 2 in SMI. What are the major changes in that version 2 or the reader is referred to for a complete set of definition? We have taken a liberty of presenting the definition with some additional commands and structural indentations to bring out clearly the being and end of macros. Right? It also having that 4 different types: new object definition macros, second one textual convention, third one table modification, and fourth one conformance and agent capabilities. From that diagram, then you simply move to the type of SMI version 2. It is nothing but textual conventions. The textual conventions are designed to help definitions of new data type following the structure defined in SMI version 2. It is also intended to make the semantics consistent and clear to the human reader. Although new data types could have been created using new ASN.1 class and tags. Tags is very important. The decision was made to use the existing defined class types and apply restrictions to them. So textual convention is in capital letter using macro. So textual convention macro conveys the syntax and semantic associated with the textual convention. SNMP based management objects defined using a textual convention are encoded by the same basic encoding rules that define their primitive types. Then one small example for that textual convention convention example. From that, let us now compare the definitions of type version 1 and version 2. It's defined that type assignment. For example, data type display string in version 1, but here RFC 1213 is having the octet string. It is nothing but textual convention 255A. With that, data type is used to model textual information taken from the NVT. And then ASIC character set by convention object with the syntax or declared or having the size 0.255. These are all the examples for textual convention. Then version 2 tables for SMI version 2 tables. From that tables, you basically know that two different tables you are having. First one static and second one dynamic. From that static tables, the structure of that MIB version 2 is development time. Then access is read only and read write. Then useful when the number of rows corresponds to a fixed attribute, example physical interface, or a quantity controlled only by agent. Vendors can add new columns to existence columns. It's a new one compared to that version 1 SMI. Then dynamic tables. In that dynamic table, it allows row creation as well as deletion by a manager. It runs at the operation time. Access includes what all the things means: read, write, create or delete privileges. These are all allowed to edit one. Then white table modification. It's fully based upon that application. Then standard MIB defines a set of parameters for NIC. For example, type, MTU, MAC, MAC. Vendor needs additional parameters, example, serial power consumption. In SNMP version 1, the vendor should define a separate new table for the parameters. Two tables different of OIDS to manage NICs. That thing is very important, and also having that these new parameters can be added to the existence table. Single table for NIC parameters. It's very easier. Then table augmentation. White table augmentation and white table modification. Application 2. It's all modification depends upon that application only. Depends upon one application. In this one application 2, it depends upon firewall rules as specified as a table, SRC IP, Internet Protocol, DST IP, SRC port, and then PRIA, proto, and action. Like that commands you are going to use. Then rules are not fixed or changed over the time. Then third point, manager want to manage the firewall using SNMP. In version 1 can't be used. It is possible to create or delete rows. But in SNMP version 2, dynamic table is the only solution to rules can be added or deleted and existing rules can be modified. These are all things available in that version 2. That's why we are simply moved to the table modification. Then table augmentation. What are the changing in columns? Simply adding new columnar objects or augmented table to an excited table. Old base table is compiled and running in agent. The MIB of the new table is defined and compiled and added to the agent. The both agent treat both tables as a single table, not a different table, only a single table. Using the following assumption, one-to-one corresponds between row of tables. Number of rows is not affected and index of the second table is the same as the first table. Then the third possible of scenario from that diagram, you can understand that third scenario is appending an aggregate object to an existing aggregate object is the case where the augmented table has fewer rows than that of the base table. This is called sparse dependent table case. From the diagram, you can easily understand that. In this Example, index for the second table is the same that for the base table, and the construct are similar to the one from that second diagram, right? Second argumentations. Then right, except that the arguments class is substituted with the index class for table 2 entry command. That is also in diagram, right? Then version 2 extends the concept table for the aggregate object for a single table to multiple table. This allows for expansion of managed object when the number of columnar objects need to be increased, or when the objects are best organized by grouping them hierarchically. Let us first consider the case of adding columnar objects to an existing table with the following two restrictions. First one, the number of conceptual rows is not affected by the addition, and second one, there is one-to-one correspondence between the row of the two tables, and in between the third point they are going to be given the index of the second table is the same as that of the first table, right? Right. In that table argumentation, one small examples I am given here. The resulting table is therefore treated the same way as if was defined in a single table definition. The table 1 as well as table 2, the value of the columnar object T2, E2 and C4 in table second 1, right, corresponding index T1, E1, C1. Let's see. This is called base table, and table 2, second one, it is nothing but augmented table. That's why it's called as table augmented, the first two things. The indexing scheme comprises two classes, the index class and the arguments class, two tables. Then the construct for the rows of the two table, and then the table entry has the index class and the table 2 entry has the arguments class that refers the table 1 entry, right? Then new table row and new table another one. It is nothing but dense dependent table is added to the base table, and sparse dependent table, the two tables, dense and sparse, is in the table argumentation. Okay, that's all about table argumentation. Then we are moved to the dynamic table, static over, then second one dynamic, major part. This dynamic table, it also having that what is that row status, create and go, create and wait, which are the actions operations in the former. The manager sends a message to the agent to create a row and make the status active immediately, but not to make active immediately from that diagram. Active, not in service, not ready, sorry, and create and go, create and wait, and destroy. These are all the commands we are going to be used in that dynamic table for existing ones. Then row creation and deletion. Example, how we are going to create the rows. Let us now analyze the create and delete operation using the conceptual table from that diagram, right? The table 1 originally has 2 rows and 3 columns. The first column status has the value of the status of the row as indicated by the enumerated integer syntax of row status textual convention. The second columnar object index is the index for the conceptual row of entry 1. Then third column object contains non-indexed data. We will illustrate the two types of row creation and row deletion operation by adding a third row and then deleting it. Then create and go row creation. From that diagram shows that go and create option or create and go row operation. The manager process initiate a set request PDU to create a conceptual row with the values given for the 3 columnar instance of the row. The value for the index column is specified by the whereby index 3. This is suffixed for the 2 columnar objects in the new row to be created. The value of status is specified as 4, which is the create and go state is seen in the table. The set request message also specifies the default value definition data for data 3, and thus all the information needed to establish the same rows and columns. Then create and wait row creation. From that diagram presents a scenario for operational sequence in the creation of a row using the create and wait method. If you see the diagram, you can understand easily. Again, this illustration takes the same scenario of adding third row on the table. Only the manager and the agent are shown, not to the managed entity in the diagram. The manager process sends a request, set request PDU to the agent process. The value of status is 5, which is to be manager process create and wait. The third columnar object accepts a default value which is not set request message. Hence, the agent process responds with a status value of 3, which is not ready. Then the manager sends a get request to get a data for the row. The agent responds with no such instance message indicate that the data value is missing. The manager subsequently send the value of data and receive a response of not in service from the agent. Fourth and final exchange of message in the diagram is to activate the row with a status value of 1. With each message received from the manager, the agent either validates or set the instant value on the managed identity. That's all the 4 columns. Then row deletion. How we are going to delete that row? The operation of deletion of the row is very simple. Set request is the value of 6, which donates destroy for status is sent by the manager process to the agent process. Then independent of the current state of the row is deleted and the response sent back to the agent. So the instant in the managed entity is deleted in the process. This is shown in this diagram. Then SMI version 2 conformance and capability. What is that conformance? This conformance statement of version 2 for the implementation of network management standards, the product generally considered compliance with a particular standard when it meets a minimum set of features in its implementation. So, minimum requirement for version 2 compliance are called model compliance, and the set defined ASN macro or module compliance in that second object. Okay. Then agent capabilities for the convenience of defining module compliance and agent capabilities, object and traps have been combined into groups. SNMP provide 2 mechanisms similar to each other, uses similar facilities, so model compliance and agent capabilities. So object group and the group of traps is defined by the notification group macro, right? Then object group macro, that's why I explained with the help of notification group. In that first object group macro class names each object contained in the conformance group. Each of the named object is defined in the same informational module as the object ground group macro and has a max access class of accessible for notify, read only, read write, read create, any of the 4. Every object that is defined in the informational model with a max access class other than not accessible is present in at least one group object group. It specifies objects in a MIP that are part of the commons group complaints. Then notification group macro, that is nothing but contains notification entities or what was defined as traps in version 1. Notification group macro in the table and diagram, from that is implementation not during runtime. So the value of an innovation of the notification group macro is the name of the group, which is an object identifier. From that object identifier, we are going to identify the group of notification required for conformance purposes, right? Then mandatory groups. Mandatory groups, it is nothing the required object and notification group that must be implemented by agent to comply the standards. Then groups, optional object and notificational group that may be implemented by agent. Then module complaints in macro, it is nothing but defines the minimum set of requirements for implementation of one or more MIB modules. The expansion of module compliance macro is done during the implementation and not during runtime. You simply note that the module compliance macro can be defined as a component of the information module or as a companion module. The status, description, and references classes of self-explanatory. This thing is very important. Then SNMP version 2 internet group. Internet group, from that internet we are going to classify into the 6 different things, the 6 different commands: directory, management, experimental, private, security of that version 2. It's all additional version 2 added. Objects added to system group, extensive modification of the SNMP group. These are all the internal group. Then simply move to the next topic of SNMP version 2 in MIB, Management Information Base. From this diagram, 2 new MIB modules, security and version 2, have been added to the internet MIB. So version 2 module have 3 submodules: SNMP subdomains, SNMP proxies, and SNMP modules. So the first SNMP domains extend the SNMP standards to send management messages over transmission protocols other than ODP, which is the predominant and predefined way of transportation. Since UDP is the preferred protocol, systems that use another protocol need a proxy service to map onto UDP. Not much work has to be done on SNMP proxies as of now. Then MIP continuation, last one. A new module of SNMP MIP has been defined, which is 2 modules: MNIP objects, SNMP MIP conformants. The last two subclassification in that SNMP MIB, right? The MIP module of SNMP MIP object address the new object introduced in version 2, the last one in the diagram in the below right end of the bottom, as well as those that are absolute. This is primarily concerned with trap, which has been brought into the same format as other PDUs. We discussed conformance specification and object groups in the previous section. These are specified under the SNMP MIP conference module. Then version 2 is currently defined. This is very strong coupling between system of MIB objects and MIB conformance modules. From the diagram, you can easily understand that. Then MIB 2, it is expanded, nothing but expanded internet MIB 2. From this diagram, new protocols and technologies we are going to be implementing that MIB 2. So SNMP network management expands, covering legally as well as new technology. Then MAB modules, and continuously it will increasing from the like that is shown in the diagram. Then version 2 was released and it has more modules than those covered in RFC 1213. It is not intended to be an exhaustive list but includes remote monitoring MIB module that we will be addressing in that particular diagram. Then system group in version 2, or otherwise it is known as changes to the system group in SNMP version 2. There are 7 entities we are having in that system group, or objects in version 2, which are common to a system, right? And then additional information is added to the system group, which contain a collection of objects that support various MIB modules. These are called object resources and are configurable both statically and dynamically, both things. Right? From that diagram, it shows that MIB tree for the system group in version 2. The sys or last change entity and sys or table have been added to the set of objects in the system group. Right? Then system group over, then protocol. Okay, in this protocol, SNMPv2 protocol, right? What are the protocols we are going to be used in that version 2? It's almost overall 8 messages with almost common messages for both version 1 and version 2. We are going to use like get request, get next request, set request, version 2 trap, inform request, and then response PDU, and last one get bulk request PDU. These are all the things we are going to be used in that version 1 and version 2 is the difference. And we will ignore the report operation which is not used. These are all the things in version 1 and version 2 operate in the similar same fashion. But extra 2 additional messages that we are going to use in that version 2, it is nothing but get bulk request and inform request. Last two things we are going to use. This command get bulk request is an enhancement of get next request and retrieves data in bulk efficiently. That's the major difference between v1 and v2. The inform request is covered, last one. Inform request is covered in a subsequent section along with SNMPv2 trap in that modified version 2, right? Then what is that? Better error handling. This is a very important one in that drawback limitation in version 1. Error codes are very limited in version 1, but in version 2 the error status is very advanced. It's like no error, too big, wrong type, wrong values, no creation, not writable, commit failed, incoefficient value. Like that we are going to be improving the error status of SNMP version 2 compared to the version 1. And in version 1 it's our atomic one, but in version 2 it's handled the errors. That's a major difference. Error status is always 0 in that version 1, but not here. Status and error index are set. This index is ignored, others are valued, or else multiple variables are failed. One variable is failed or multiple variable. Only error status is set, all variables are ignored. That's the major difference between SNMP version 1 and version 2. That limitation going to be overcome in that version 2. In that same better error handling, we are going to do that exceptions. What is that? Exceptions means 3 different things we are going to use: such, object, instance, and view. Used get next and get bulk. That exceptions does not raise error. That is the main thing. They are encoded in variable binding. So it having the better example, better performance. For example, 10 object identifier is requested, 2 object identifier is wrong. But in version, it having the such no such name like that they are displayed. But in version 2, 8 values are returned and wrong values is no subject object. That is, it is nothing but 2. 10 out of 2. Version 2, they are identified the 8 thing. In version 1, like error no such name like that they are going to be displayed. That's a difference in error handling. Then SNMP version 2 having that main message, it is nothing but get bulk request, BDU operation. What's the difference means, its operation is added in version to retrieve bulk data from a remote entity. That's the main advantage. Bulk data, retrieve bulk data. Its greatest benefit is in retrieving multiple rows of data from a table, and then basic operation of get bulk request is the same as get next request. Both should be same. Third and fourth field position are used to get bulk request message as non-repeaters and max repetition. We are simply shown in the figure. Then the non-repeater field indicates the number of non-repetitive scalar objects to be retrieved. The max repetitions field defines the maximum number of instances to be returned in the response message. This would correspond to the number of rows in an aggregate object. That's the main thing we are going to use in that error status field, replaced by non-repeaters, and error index field replaced by max repetitions. That's the difference. Then get bulk request, same thing. From this slide, to illustrate the operation of get next request and then get bulk request in that PPT, it is similar with 2 additional rows added to be table to notice the difference in improvement of get bulk request over get next request. From that slide, we can easily understand that non-repeaters and maximum repetition, N and M. N is for next objects of N given objects are asked, but M max repetition, it represents at most M successive objects instance of each or repetitive objects are asked. It is nothing but get bulk request. Then get next, right. Right. Then get next request. From this diagram to notice that difference to improvement of get bulk request over get next request in the diagram, which shows that sequence of operation for get next request for the MAB. So here it is subsequently followed by the get next request message with 3 columnar. It is nothing but object identifiers TE1, TE2 and TE3. So get response in terms for the first instance value TE1, TE2, 0.1, TE3.1. The sequence of operation continues until the 4th instance is retrieved. Up to that it continues. The last get next request message with the object identifiers is the last one, TE1.4, TE2.4 and TE3.4. It generates the value TE2.1, TE3.1 and Z. This is the last one, right? Then this is because there are no more instance of the table. It retrieves 3 objects, which is logically next lexicographically higher objects, namely TE2.1, TE3.1 and Z. The manager would stop the sequence at this message. However, if it continues the operation, it would receive a no such name error message. So this diagram shows the sequence of operation to retrieve the MAB message using the get bulk message. The entire MAB data are retrieved in two requests. What is that? First request is nothing but get bulk request, and second one, it is nothing but entire thing. It is nothing but second one, same thing is required to receiving non-repetitive objects, and third repetitive instant of the columnar object TE1, TE2 and TE3. That's all about get bulk request operation. Then trap version 2 having that trap and inform request. This is already studied in that same thing in version 1, but what's the difference here? Both use the same PDU. Then PDU performs same function as in version 1, same. As we notice, the name has been changed as well as data structure to the generic format in that diagram. The variable bindings in portion 1 and 2 are specific as sys uptime and SNP trap OID from that diagram, last two boxes, right? The destination to which a trap is sent is implementation dependent. So notification type macro, the macro contains objects class, then the objects defined by the class are in the variable binding in the order of particular response for inform, right? Then summary of finally we are going to be summary of that SNMP v2. It is nothing but new messages manager to manager is possible, and bulk information transfer is possible in that SNMP v2. Then better error handling including exception is possible in version 2, and table modification, textual convention and conformance MAB improvements is also available in version 2 compared to version 1. Then compared to that SNMPv1, it is more powerful and more complex in SNMP version 1. All right. Then finally, SNMPv2 failed to improve on security. That's the main drawback and disadvantages of version 2. So we are simply move to the version 3, SNMP version 3 for improve the security, authentication and encryption, like that. That's the difference between V3, V2 and V3. So V1 similar to V2, both should be little bit similar, little bit difference only is there, but compared to the V1 and V2, V3 have more security. That's why we are simply move to the version 3, SNMP version 3. So in this summary, SNMPv2 failed to improve on security. That's the main drawback. Thank you.